We are doing a big deal today. A big deal. Up until today, you knew of 4 operations in math. You knew how to add, subtract, multiply, and divide. You didn't even know there was another one out there. There is another one out there. It's called composition. So you start thinking, I've heard that word before. Yeah, in English, we talk about compositions. Compositions are where you take a bunch of words and you put them together in such a way that they form nice sentences and a nice story and all of that kind of stuff. So what we're going to do in math is we're going to take some functions and we're going to put our functions together and see what we get. That's what composites are. So we're using more than one function at a time to solve things. So we had our little objectives down here and there were 2 of them. And we got through the top one here yesterday. That's subtract, multiply, and divide. In fact, we did a little more because we talked about the domain. So today we're going to talk about the composite of 2 functions. And we're also going to talk about the domain, because that's important. Giving people those warning labels that say, use this, but don't use this number. This number would be bad. So let's see where we are. Oh, yep. Got to introduce you to composites. Or my computer is slow. Drum roll. Took it a while. Get to that drum roll. Time to introduce you to a mathematical operation you have never seen. This operation is so profound that history does not record who came up with it. Usually, if we go back and look at autobiographies, biographies of famous mathematicians, we'll see, hey, this person came up with big stuff in this. But occasionally, what happens is 2 or 3 people are all studying the same thing at the same time. And it's like they all have their eureka moment at the same time, and they don't name it after themselves. And this was kind of one of those things where more than one person was working on it at one time. So what we have to do is learn about today's star, composition, charge. Now the good news is, it won't be the hardest thing you've ever done. It won't be. But what we have to do is make sure that we understand it, because we have some new notation. And that always takes a little bit to get used to. So the box on the top of the next page says we've got some key concepts for composition of functions. Oh, was there more at the bottom of that page? There's a little something or other down there. There it is. The diagram shows what happens when you apply one function after another function. Okay? So we take a number and we put it into a function and we get something back. There's the something back. And then we say, you know what? I'm going to put it through the other function too. And we put it into that function and it kicks something out. So this is like a little machine, really, that is supposed to show us that we only have one input. We put it into the first function and then everything comes out all at the end. So when we talk about domain, what we really care about is which one are you starting with, because that's the one that lets you know what you can put into the function. So the output for the first function becomes the input for the second function. And when you combine 2 functions in this way, it is called a composite function. So we put them together. Now, sometimes we don't have to put them together. There are ways to get around it if they give us numbers. And that's one of the things we're going to learn is that if we have numbers, this is not that bad a deal. It's just not. It gets a little more complicated when you're talking about equations, but if you pay attention today, you shouldn't have any trouble. So, back to the box. Composition of functions. Here comes the notation. The composition of function g with function f is written as g little bubble f. Okay. Little bubble means composition. Now, what that also tells us is the order that we're supposed to do this in. So if they give us g little bubble f of x, here's what we're supposed to do. We're supposed to take x and put it in the closest function first. So we're going to put it into f of x, and we're going to get a number. And then we're going to take that number and put it into g. Now, if I tilt this sideways, do you see how it kind of looks like a sideways S? Can you do that? So it goes into the closest function first, and then it goes into the other function. Now, the better way to write that is with parentheses. So g of f of x with parentheses looks like this. Why is that better? Because we have a rule about parentheses in math. And the rule is you always do inside parentheses first and work your way out. So when it's written like this, it's really obvious. Hey, we're going to do f of x first, and then we're going to go out and do g of x. So if you don't like the little bubble thing, because some books don't even use that. Some books just use the parentheses. You can always rewrite it so that you're saying this is g of f of x, g of f of x, and then the parentheses part will help you out. So it says g of f of x is the same thing as g parentheses f parentheses x, and you finish off your parentheses. You have to start here first and then go into the second one. Here first and then there. Closest one and then out. So problem 3 says we're going to do some composition of functions. For f of x equals x minus 5 and g of x equals y squared, what is g of f of negative 3? Now here's the first thing I want everybody to understand. We don't put x over here. F of x is fancy notation for y. It's just fancy function notation. That's all it is. Same thing here. G of x is just fancy function notation. For some reason I was mixing fancy and function and the fancy. And this says, what is g of f of negative 3? So, if you don't mind the bubbles, you're going to put negative 3 into f. You're going to get an answer, and then you're going to put it into g. But I don't like the bubbles, so I rewrite it like this. So what I need to do is put negative 3 into f, get my answer, and then put it into g. So here's f of x. I put negative 3 in here because it's always the x's that we use for input. And I say negative 3 minus 5. That's negative 8. Well, now I work to the outside, which is g of x, and I'm going to put negative 8 into g of x, which is x squared. So I need negative 8 squared, and that's 64. So you put it into the first function, then you put it into the second, and you're finally done, and here's your answer. Now, MCAs will be here before we know it. And one of the things they like to do on the MCAs is what they call the gridded response. So you do all that math, and you notice, uh-oh, this is not multiple choice. They're going to make me fill in some boxes. There's good news and there's bad news. You can go all the way to the left, put in 64, color in the 6, color in the 4, and get full credit. You can go all the way over here, put in 64, color in the boxes, and you'll get full credit. You decide, I'm going to put 64 right smack dab in the middle. The computer will mark it on. It has to be all the way to the left or all the way to the right. Never in the middle. It's just part of their grading practices because their computer is not a human. It's just trying to read off the pencil, the graphic. So always all the way to the left or all the way to the right, never in the middle. So now let me rewrite f of x and g of x down here. F of x was x minus 5. And g of x was x squared. Because this one says, let's find f of g of negative 3. Oh. So f of g of negative 3. Okay. So this time I have to put negative 3 into g first. So that'll be negative 3 squared, which is 9. And then I go to the outside, which is f, put it in there, and 9 minus 5 is 4. Wait a minute. Do we get 4 for the answer for the one above this? What do we get for that answer? Well, we put negative 3 into this. We put negative 3 in. Carson's got it. It's a different order. Composition does not work both ways. F of g of x is not always going to be the same as g of f of x. We're not guaranteed that. It's not like multiplication where you do 3 times 4 or 4 times 3 and it doesn't matter. It matters big time in composition, which way you do it. So that's why it's important that we know which one goes in first. Now I know you've got some spare space on that page because I am going to make up a problem and let you guys do one. Spare space down there. F of x equals x plus 3. G of x equals x squared minus 1. I want you to find the f of g of negative 1. Which function do you put it into first? G. You put negative 1 in G. See what you get. Once you have that answer, where do you go? F. What's the answer, everybody? 3. It is 3. We take negative 1 and we put it in here. But negative 1 squared is 1. So 1 minus 1 is 0. And then you put 0 in here. And 0 plus 3 is 3. I don't want to squeal on anybody, but there are some people that just wrote the problem down and didn't try that. So we're going to have to do another one. Because I want to make sure you all know how to do this. Now, know that this is always legal. It is always legal for you to use a chicken wing elbow partner. So if you're struggling and I'm walking around and I'm looking for answers and you don't know what to do, it's okay for you to ask somebody that sits next to you, your little chicken wings there. Try that one. At least write down the answer. You know, I know some of you too write down every step, but at least write down the answer somewhere where you can point to it. What is it, everybody? It's a little 2. A little 2. Negative 2 in f. Negative 2 plus 2 is 0. 0 squared plus 2. A little bit of 2 there. So this is just knowing which one do I go after first. And like I said, you can write it so that you're thinking inside parentheses, or maybe you really like the bubble thing. And doing that one first, and then putting it in that. Whichever way, as long as you can get it, that's all that matters. So now on the next page, there's something different. Composing functions and identifying domain. Let f of x equal x squared minus 4 and g of x equal x plus 7. Find f of g of x and find the domain. Oh, all right. F of g. Where's the number? There's supposed to be a number in there. Not every time. Sometimes they want to know, if you did compose these two functions, what would your new formula be? So this is saying we're going to take g of x and we're going to put it into f of x. What are we supposed to put? I mean, if we take g of x and we put it into f of x, here's g of x. Where do we put it? Well, where did we put the numbers when we put them in? X. That's what we do. We put this right here for x. And we say, okay, here's our new one. It's x plus 7 squared, because we had to put it right there, minus 4. And then we figure out what it is. You see it now? Yeah. Yeah, always innermost parentheses first. So that one goes into the other one. So now what we do is we'd say, well, this is x plus 7 times x plus 7. We know that part. So that's going to be x squared plus 14x plus 49 minus 4. It's just simplifying. That's it. So x squared plus 14x plus 45 is f of g of x. So you literally, composition is just a fancy name for substitution. That's all. Just take the inside one and substitute into the other one. Again, we never put them on the side with the f of x and the g of x because that's y, and that's output. It's input. Speaking of input, that's what domain is about. So domain of f of g of x. So what I have to figure out is, which one did I put into the other one? Which one did we put in? G of x, because that was inside. So all I have to do is figure out, are there any numbers I can't use in g of x? Because that was the one that was the input. So do you see any square roots, fourth roots, sixth roots, anything like that? Okay, how about division? You see any division here? All reals. Notice I don't do them both. The only one I do the domain for is which one is the input, which one is going into the other function. That's the one that we have to check the domain for. And x plus 7 doesn't have any restrictions. So let's go down here. This looks a little tougher. Let f of x equal the square root of x minus 3 and g of x equal x plus 2. Find g of f of x and find the domain. Which one's going into which one? This one has to go into this one. So g of f of x means we start with f of x and we put it into g of x. Square root of x minus 3 plus 2. There isn't anything we can do with that. We can't add those two together. We're not solving. We're just coming up with a new formula. So we can't square it. We can't do anything like that. We just have to leave it. I like that one. Looked like it was more complicated, but all we do is write it and say, I can't have a square root. It's done. Except for this part. The domain of g of f equals. Which one went into the other one? F went in. Uh-oh. That's square root. So, square roots, x minus 3 is going to have to be greater than or equal to 0. Because if it's not, then we are doing imaginary stuff. You know, if it came out to -1, we'd have to put, well, that's I. But we can't do that. So x minus 3 has to be greater than or equal to 0. We just solve that by adding 3. X has to be greater than or equal to 3. There's our domain. There it is. So you take the function that's in the innermost parentheses. Don't flip the page yet. I got to give you one to check and see if you know it. Let's use some of that space. I'll turn it sideways or something, or use the little lines on the side. Let's try f of x equals the square root of x plus 2, and g of x equals x minus 7. And let's do g f of x. Oh no, it's a little long there, isn't it? It's just over the x. Yeah, you're right, Chris. I should erase a little bit of that. It's trailing a little bit. Better. That's better. Domain 2. See, lots of right answers, but do the domain as well. Okay, everybody, what should I put behind this? Can you do 2 minus 7? Just like that. Now our focus is on which one was the one that went into the other one. And this definitely has a restriction on it. What kind of numbers can we use under there? Can you use -1? You can. It's just going to be imaginary. You can't do imaginary. Can you do 0? Square root of 0 is 0. How about +1? So we have to say x is greater than or equal to 0. Those are the ones that are going to work. So we can't just say positive numbers because 0 is not a positive number and 0 has a neutral sign. So that's what we have to do when they don't give us a number to put in. That's a little more complicated, but the good news is this is something you do deal with all the time when you go shopping. One of the things that they found out as they try to sell us stuff is that because of the economy, people are looking for better and better things. They really are. So to say, you know, use this coupon sometimes isn't enough, because you wait until you see not only do you get the coupon, but you also get an additional 25% off or something along those lines. So you know you're going to even get a better deal. So this one says, going off the pizza, You got a coupon, it's good for $5 off the pizza. And you also get a 10% discount on any pizza if you show your student ID. How much more would you pay for a large pizza if the cashier applies the coupon first? Well, that implies that one of these ways is the better deal for you. Okay, so let's say we walk in, we don't know how much the pizza is because we're not standing at the register right now. And we say, coupon first, take this $5 off. And then we remember, oh, got my student ID with. Here's my student ID. So I want that 10% off also. Well, it's great that we get 10% off, but what we care about is what we pay. So if it's 10% off, how much are we going to pay? So this is using the coupon first. The other thing that can happen is we walk into the store and go, oh, yep, got student discount. I'm a student. Here's my ID. So they take 90% of the cost of the pizza to charge us because the other 10% are taken off. And then we remember, oh, got a coupon. Hang on, it's in here somewhere. Bring out that coupon for $5 off. So this is the discount first. And this one is done. There's no math we can do there. It's just as it is. Is this done? We've got to distribute. 0.90x minus 90 cents times 5, that's $4.50. Hey, they didn't come out to be the same. Which one's the better deal? Discount first, because you get your 10% off, and then they take $5 off. Here, if you do the coupon first, you get your 10% off, but then they only take $4.50 off, because that's how the math works. So, 50 cents. And if you're saying, well, it's just 50 cents, it's no big deal. Well, it's your 50 cents. It is a big deal. You get everything you're entitled to. So, when there's a coupon and there's a discount, it doesn't matter which one goes in first. And some businesses will let you choose. They'll say, what do you want to do first? And you need to know that you'll save a little bit more money. Especially when it's something, I mean, we're talking pizza. Pizza's not going to be that expensive, but if it's furniture or something like that, yeah, you want to be able to get it. So this one says, we've got some discounts. A store is offering a 15% discount on everything in the store, and you work in the store. So all employees get another 20% employee discount. And they want us to write the composite functions. The first one, taking the 15% discount first. Okay. So if we're not paying 15%, how much are we paying? 85. So this is going to take the 85% off first. And then the 20%, if we're not paying 20%, how much are we paying? They're not the tough questions, everybody. 20% off, good, 80. So we'll take 80% of that. All right, let's see what that is. 0.8 times 0.85, because some of you maybe don't have calculators. 0.8 times 0.68x. That's not bad. So we end up paying 68% of the cost. Well, let's see if this is better. B says, take the 20% off first. Okay, you guys just told me that was 80%. What was the 15% discount? How much did we pay? 85. Well, wait a minute. Isn't 0.8 times 0.85 the same thing as 0.85 times 0.8? That's what they wanted us to see. If it's a coupon, doing it one way versus another way is going to give you an advantage. But if they're both percentages, it doesn't matter which way they do it. You're going to get the same discount in the end. So when C says, if you were an employee, which discount would you take first? That's just silly because it doesn't matter. It doesn't matter. So today, while we're going through our objective about composite functions, we started off with oh, let's just take a number, put it into one, get an answer, put it into another. And then we went to the tougher ones of actually take the function and put it into the other function. And then we went to the real world and said, you know, what's the discount here? How much did we get off? So that's what we would want to apply all of this to. 43210, how you feeling? Composition. You doing all right? Okay, well then it's a good thing we've got some more time. That way you can get started and I can help out anybody that's feeling a little stuck. There we go. Wait until you get it down and then I'll turn the lights on because lights seem harsh.